I'm Gary, and I have an appetite for geochronology. So apatite happens to be the mineral that your teeth and bones are made of, but it also occurs in igneous and metamorphic rocks and the sediments that form from them. It's a calcium phosphate mineral, but it also contains trace amounts of uranium when it forms, which over time decays to lead. So by measuring the ratio of uranium to lead, we can date individual apatite grains, because we know how fast this reaction takes place. So I've been looking at sand samples, and the reason is that over time, mountains erode, they're weathered away, and eventually the only evidence we have that they ever existed is from sand deposits. So the first part of my PhD consisted of painstakingly sampling tiny individual apatite grains with tweezers under a microscope hundreds of times. But you know, that's what a PhD is all about. And I've gotten some pretty interesting results. So I've been working on a river in North Carolina called the French Broad River, and previous work has been done in this river dating sand samples from the rivers with mineral zircon. So this is a graph that shows the number of zircon grains and their age in millions of years. So the peaks correspond roughly to periods of high geological activity and important events in geological history of this area. However, 300 million years ago, approximately, the supercontinent Pangaea formed, and this area was integral to that, and zircon doesn't show that. This is due to the particular way in which zircon forms. So my apatites, however, do show this event forming, whereas perhaps they're poor at showing older geological events. So to sum up, I would argue that including apatite in mineral dating studies will give us a fuller picture of the Earth's past. Thanks.